So, this is our sixth lecture of our subject digital system design, and the topic for today's lecture is 6 variable K-map and tabulation method. So, these are the contents of today's lecture, 6 variable K-maps, and before that we have already covered K-map up to 5 variables, and in the last lecture we have seen that 5 variable K-maps became quite complex, because for a K-map we need 2 raised to the power n number of cells, where n is the number of variables. So, for 5 variables cells became 31. So, we have to split the K-map into 2 parts of 16 each. Similarly, in that 6 variable K-map we will see that the structure will be more complex than even the 5 variables. So, because in that 6 variable K-map 2 raised to power 6, that means 64 cells will be required. So, in that we will be breaking the K-map structure of 64 cells into 4 K-maps of 16 cells each. Okay. We will be covering that, and then we will be covering the tabulation method. So, let us start with the 6 variable K-map layout. So, how to prepare the K-map layout of a 6 variable problem? Let us suppose the 6 variables are A, B, C, D, E and F. So, if I mark these 6 variables as A, B, C, D, E and F, you can see that from this layout I have chosen these 4 variables C, D, E and F to prepare 4 identical K maps for 4 variables C, D, E and F. This is using C, D, E, F, again C, D, E, F, C, D, E, F, C, D, E and F. Okay. But A and B are changing for these 4 C, D, E, F based K maps. Here we can see that A B is equal to 0 0. Similarly, again repeating that same K map for C D E F, for A B is equal to 0 1, then similarly for A B is equal to 1 0, and similarly A B is equal to 1 1. So, we have break down the 64 cells into 16 cells K map in this way. So, we can see that the first K map is covering the minterms from 0 to 15. The second structure is covering the minterms from 16 to 31. The third is covering from 32 to 47. The fourth one is covering the minterms 48 to 63. So, in this way 0 to 63, 64 minterms are being covered by these 4 K map layouts, which are identically variabled from C, D, E and F. So, this is the K map layout. Now, what are the grouping possibilities? In 3 variable problems we have seen, in 4 variable problems we have already seen that there are quads, there are octets, but these quads or octets were limited to only a single layout. So, that thing we have to keep in mind, that if an identical quad, either in the form of a row or in the form of a column, or there can be 4 adjacent ones, these quads if they are appearing multiple times in these similar K map layouts, then we have to increase the size of that group that many number of times. Okay. So, let us check this. These are the grouping possibilities in a 6 variable K map, as can be seen from this layout, that this one, if there is a 1 here and there is a 1 here, then these 2 ones will be adjacent singles, they will be treated as a pair. Okay. Similarly, you can check that this is a quad, this is a quad, okay. This is also a quad, this is a quad, and this one also a quad. So, these are 4 adjacent quads. Okay. So, the size, technically speaking, that size will be 4 into 4, that means 16 minterms are being covered by this single group. Okay. So, if a group is being formed in all 4 K map layouts, then A and B will be eliminated from that. Okay. This is the key point. So, if I am using a group in all 4 K map structures, then that particular K map, then that particular variable A and B will be eliminated from that question or that problem. Similarly, we can see that this is an octet, and the same octet is being repeated here as well. So, these are also adjacent, these are adjacent octets. here it is mentioned, these are adjacent octets, and it will also be considered as a size of 16. Okay. Similarly, we can check that if this is a row, a quad is being prepared there, and a similar quad is being prepared in this K map as well. So, these quads in form of rows will be considered adjacent, that means 4 plus 4 it will be considered as an octet. Similarly, we can see that this is a column and this is also a column. So, these two columns will be considered as adjacent columns, again the size will be 4 plus 4 8. Okay. So, in this way we can say that if a group is being repeated twice or 4 times, then it will be, the size will be considered either into 2 or either into 4. So, these are the grouping possibilities in a 6 variable K map layout. So, now let us cover the problem which is being based on this 6 variable K map method. So, there are 6 variables A, B, C, D, E and F. So, these are the minterms which are being provided to us. So, these minterms are first to be fed into that K map layout. We can check that 0, 4, 8, 12. So, 0, 4, 8 and 12. So, these are the 4 minterms which are belonging to this first K map. Then 26, 7, 30 and 31, these are the 4 which are belonging to this second layout. So, 26, 27, this is 26, this is 27 and then 30, 31. Okay. Then 32, 36, 40 and 44, these 4 are related to this third K map, 32, 36, 32, 36, 40 and 44. Okay. Then the last two, 62 and 63, 62 and 63. So, these are the minterms which are being entered into this 6 variable K map layout. Now, how this grouping will be arranged? We can easily see that this forms a quad and there is an adjacent quad to it in the third K map as well. So, these two will actually form an octet and I can label it as group number 1. Okay. Similarly, we can see that this also forms a quad and there is no such adjacent quad, there is no quad identical to this one in other layouts. So, this is the only possibility for this 4 minterms. So, this becomes my group number 2. Similarly, we can see that these two can be merged with these two. So, I can say that this prepares my group number 3rd. So, there are 3 groups 1, 2 and 3. First one is a merger of 2 quads, that means it becomes an octet. Similarly, there is a standalone quad here and then these 2 pairs again form a quad. So, we can check that this corresponds to E f is equal to 0 0. So, from this first K map, first group will provide me an answer E bar f bar, E bar f bar, and also it has A b is equal to 0 0, A b is equal to 1 0. Then again we can see that this 0 is common here, this 0 corresponds to B bar. Okay. So, this 0 corresponds to B bar. So, that is why we are writing here this becomes B bar and that A plus A bar will be eliminated. So, this is the answer from this first group. Similarly, we can continue with this second quad. This second quad here we can check that from the row side this one is common, this one corresponds to C, and from these 2 columns this one is common which corresponds to E. So, from the second group I am getting the answer C E, and this quad is only present in this second K map which corresponds to A b is equal to 0 1. Okay. So, I am also adding A bar B to it. So, this has A bar B C E. This is the complete answer from this single quad. Similarly, from this third quad which is actually the sum of two pairs. So, I can see that this 1 1 corresponds to this 1 1, these two ones correspond to these two 1 1, that means it becomes C D, and these two columns are involved which gives me E as common. So, C D E, it is very much clear that C D E will be present, and then again these pairs are identical in these two K maps. So, A B is equal to 1 1 and A B is equal to 0 1. I can see that A B is equal to in this that 1 which is corresponding to B, it is common here. So, I will be using B, C, D and E. So, I am in this way I have prepared answers for all these three groups, and they are being written separately and they can be added together to obtain the final answer. So, in this way if I add 1 plus 2 plus 3, this will be my final answer of this 6 variable K map. So, in this way we can solve any 6 variable K map problem. Now, continuing with the second topic of our today's lecture, tabulation method. So, this tabulation method is very useful. Why? Because when we have seen in our previous lecture and today's lecture as well, when we were solving 5 variable problems and 6 variable problems using K map, the structure was quite complex and it was not easy to find the groups, and it was also not easy to determine the size of groups, because a single group can be available in multiple K maps. So, we have to be very careful while solving 5 and 6 variable problems using K map. So, there is an alternative method which is also known as tabulation method, which was being proposed by this scientist Quine-McCluskey. So, it is also known as Quine-McCluskey method, and it is suitable for solving 5 and 6 variable problems where min terms are quite large, and minimized expression is obtained by preparing a series of tables. That is why this method is termed as tabulation method. There is no special reason why this is called tabulation method, because a series of tables are involved in solving the K map, in solving the problems. That is why this method is known as tabulation method. So, now let us consider this question 0 1 2 3 5 7 8 12 10 12 13 15. So, it is a 4 variable problem. We have to minimize this 4 variable problem using tabulation method. So, there are some steps which have to be followed. So, the first step is writing all the terms in binary form. So, these terms 0 is written as 0 0 0 0 in 4 variables. Similarly, this 1 0 0 0 1. Similarly, we can write all the terms, this 15 is written here like 1 1 1 and 1. So, in this way all the min terms are translated into their binary equivalents. So, and after writing all these min terms in binary, then we have to find how many ones are present in these terms. So, we can check that in this first min term there is no one present. So, I have mentioned 0 here, and this I can check there is a single one here. So, I mentioned 1, again I can see that there is a single one 1. Now, there are 2 ones here. So, I have mentioned 2. Similarly, I can see that there are 2 ones in this one as well. So, I have mentioned 2 again. So, this thing, the number of ones in a binary number, in a binary message is termed as the index of that binary message, okay, or a binary data. So, we have calculated the index of all these terms, binary terms. So, now the next step is arranging these terms in increasing order of their index. So, we have to arrange these terms in increasing order of their index. That means, first the terms will with the 0 index, definitely there will be a single term with 0 index, that is the 0. Then after that the terms with 1 index, then 2 index, then 3 index, and there will be single term with 4 index like this one 1 1 1 1. So, we have to arrange these min terms in a table in the increasing order of their index. So, if I arrange these terms, I get this kind of a table here. So, you can check that 0 has index 0, there are all zeros, then 1, 2 and 8, these are the 3 terms which are having single ones, this one and this one. Similarly, this 3, 5, 10 and 12, there are 2 ones here, and it is mentioned here that it has index 2. Similarly, 7 and 13 have 3 ones each, and it is mentioned here that they have index 3. Similarly, this 15 has 4 index, and it is mentioned here. So, we have arranged all these terms in increasing order of their index. So, now these things, these groups, these minterms from these index groups are to be grouped together. And what is the grouping criteria? All these terms, all those terms can be grouped together which have a single bit difference. That means, all three, it is a 4 variable problem A, B, C and D, that means 3 positions have to be identical, and the number can differ by 1 bit position, and such combinations can be converted into groups, and all those minterms which are participating in a group have to be ticked, and this ticking is very much important, because in the end we will see that the terms which are not ticked are the ones which are actually required. So, if we leave a tick by mistake, then I will be getting an extra term which will lead to a wrong answer. So, ticking is also very important. So, we can check that this 0000 and this 0001, these are identical at these first 3 positions. So, I can mention here that there is a group formed of 0 and 1 term, 0 and 1 are grouped, that is why I have ticked them, and they can be grouped like 0. So, this D I have left for difference, which I will be using later on at later stage. So, I am not using D right now, I am erasing it. Okay. So, 000 is identical and there is a difference at this position. So, I am replacing this position by a dash, because these two terms 0 and 1 are different at this last position, and this different position is being replaced by a dash. Similarly, I can check that 0 and 2 are different at this position, 0 0 dash 0. So, 0 and 2 are also forming a group 0 0 dash 0. Okay. So, I am again ticking 2 because it has participated in a group. Similarly, I can check 0 and 8, 0 and 8 are also forming a group at this is the position of difference. So, it becomes dash 000. So, in this way 0 has been grouped with 1, 2 and 8, all 3 terms. So, we have to check for all possibilities. So, in this way grouping of index 0 terms and grouping with the groups with the terms in the one index group is complete now, and there are 3 groups which are being prepared, and similarly I have to continue this with 1 and 2 as well. So, now the terms from one index group will be combined with the terms from second index. So, 1 and 3 can they be grouped? We can check that 0 is same, 0 is same, 0 1 what it is different, 1 1 it is same. So, there are 3 positions which are exactly same. So, 0 0 dash 1. So, 0 0 dash 1 and it is merger of 1 and 3. So, 1 and 3. I have again ticked 3 because 3 has participated in that group. Similarly, I can continue with this table, and if I continue like this, I can check that this difference can be used in the further stages, where I will be writing the difference here 0 1 minus 0 is 1, 2 minus 0 is 2, 8 minus 0 is 8, 3 minus 1 is 2. Okay. So, this is how this table is going to be prepared. We have to show the partitions where the grouping from one index with the terms from the other index have been completed. So, I have to show a partition here, and here I have shown it with a different color code, but in your case you can simply dark that position like this, that there is a partition here and the grouping of 0 and 1 index is complete. Okay. So, I have simply calculated this, and after this calculation I can see that this kind of table will be prepared, and I see that all these terms are covered. Okay. All these terms are covered. So, I have placed a tick everywhere in the first stage. That means, in my answer, while calculating the answer, none of these terms are going to be used. Okay. So, this is my updated table. As we have seen from the previous slide, I have prepared these 4 values. Similarly, I can prepare the values for the next stages as well. So, this tabulation, I have prepared another table from the first table. That is why it is we have already mentioned, it is all known as tabulation method. So, we have prepared another table, and now we have to again group these terms, group these 3 terms with these terms. If I erase this, then it becomes more readable. So, these 3 terms are to be merged with these terms, that means one group is to be covered with another one. So, we can check that, and the criteria which will help me in grouping is that wherever I see the difference is same, there is a difference 1 here, there is a difference 1 here, and there is a difference 1 here. So, they can be grouped. So, only those terms will be considered for grouping where the difference is same. So, I can check that 0 1 and 2 3, they have same difference. I am not saying that they will be definitely grouped, but we will be checking only those ones where difference is same. This is the minimum criteria. I am not saying that if this criteria is satisfied, there will definitely be group, but this at least reduces my work, that I have to not check all terms with all other terms. That means 0 1 and 2 and 3, there is a possibility here, and we have to check whether they will be forming a group or not. So, 0 0 0 dash and 0 0 dash 0 0 1 dash. So, this term is under consideration with this one. So, 0 1 0 0 dash and 0 0 1 dash, we can check that 0 0 and last dash are common, and this is the different point, rest are same. So, I am mentioning here 0 0 dash dash, and the terms involved are 0 1 2 and 3. Okay. So, I am ticking this 0 1 and I am ticking this 2 3. Similarly, I will check, I can see that this 0 1, we need not to see this 0 1 grouping with any other term, because this difference is not 1 anywhere else. Okay. Then we can check that this 2 is 2, this 2 is here as well. So, 0 2 1 3, 0 2 1 3, I can again see there will be same group. So, 0 2 1 and 3 will also be used, 0 2 1 and 3, but these 0 2 1 and 3 will not be written anywhere, because it is already mentioned here that they are identical. Okay. Even if I write this 0 1 0 2 1 and 3, they are not going to be used, because I can see that these 4 terms are identical here. Okay. So, there is no need of it. So, I am erasing it, but the thing is that they have to be ticked. So, I have ticked 0 2 and 1 3, this tick cannot be missed. Okay. So, in the similar pattern, this 0 8, we can see that there is term 2 10, 0 8 2 10, they are also 0 8 2 and 10. So, I am taking 0 8 and 2 10, and the resultant is 0 0 dash 0 and 1 0 dash 0. So, dash 0 dash 0. So, this becomes my another group. Similarly, I can see that there is no more grouping possible. 0 8 with 2 10, 0 2 can be merged with this 8 10. So, this 0 2 is already ticked, 8 10 can be ticked, but this 0 2 and 8 10 will result in the same group. So, I am not mentioning here. So, in this way, this stage has to be covered with, has to be updated with the next stage. Similarly, I can group these 2 groups, and it can be completed in this way. So, this prepares the next stage table. Okay. And here the important point to be seen is that this is the participation status. Tick shows that they have participated, but this thing has not participated, this is also not participating. So, I have given name to them P Q. Similarly, these 4 terms cannot be further grouped, these 2 cannot be grouped with this one. So, I have named them as well, because there is no further grouping possible. So, I have mentioned these as my prime implicants. So, these P Q R S T and U. So, these are being labeled here as P. How this is written? P is covering 8 and 12. 8 and 12 means dash 1 dash 0 0, that means A is there, B has been eliminated, C bar D bar. So, A C bar D bar here. Similarly, you can check U, this U, how this U is written here. You can see A is being eliminated, C is being eliminated. So, these have been eliminated, and this is 1, this is 1. So, B D. So, that is why U is equal to B D, it is written here. Okay. So, in this way I have prepared the table, and I have identified the terms which had not participated in the grouping. So, these non participating terms are the prime implicants. So, these are the prime implicants P, Q, R, S, T and U. So, now I have to prepare the prime implicant chart. So, P, Q, R, S, T and U, these are the 5 prime implicants now. So, P is covering 8 and 12. So, I mentioned here 8 and 12. Similarly, Q is covering 12 and 13, Q is covering 12 and 13. R 0, 1, 2, 3, 0, 1, 2, 3, you can see that R is covering 0, 1, 2 and 3. Similarly, I have mentioned the terms which are being covered by this P, Q, R, S, T and U in this table. Now, the most important point and which will be providing me the final answer of my problem, I have to check these problems column wise, these things column wise, and I have to identify those crosses which are single. That means, I can check this column give me 2 cross, that means there is not a single cross. So, I am not interested in that. Again I can see there are 2 cross, 2 cross, 2 cross, 2, 2, 2. This is the column with a single cross, I am interested in this. Similarly, this one and this last one is another column with a single cross. So, these crossed circled cross are very useful. So, this shows me that this S, now I am checking the rows wherever there is a single circled cross. So, I can see that S is offering me a circled cross, I have highlighted S and I have also highlighted U as well, because it is also giving me a circled cross. Now, S plus U are my essential prime implicants. Okay. S plus U are the essential prime implicant, that means they will definitely be the part of my answer, but the answer is not complete. We have to check whether this S and U are covering all the terms. So, to check, S is covering 0, 2, 8 and 10, and this U is covering 5, 7, 13 and 15. Okay. We can see that 1, 3 and 12 are still left. So, we have to use more terms from here, P, Q, R, S, T, U, P, Q, R and T. So, there are 4 prime implicants still left. I have to choose minimum prime implicants to cover all these pending terms. So, I can see that this 1 can be covered, this 3 can be covered, 1 and 3 they can be covered with the help of T. So, I am using T for including this 1 and 3, and this 12 can be covered using either P or Q, plus P or Q, I can take any one. So, my answer will be S plus U plus T plus any one from P or Q. Okay. So, in this way I have to just replace this S, U, T and P, Q by these terms. So, S is, you can check from here, it is B bar, D bar, U is B D plus 1, anything from P or Q, I am choosing P. So, A, C bar, D bar and T is your A bar D. So, this prepares my final answer. So, this is the final answer of this tabulation method. Now, if there are don't care terms also provided to me in this tabulation method problem, I have to just skip those don't care terms while preparing the PI chart. That is the only difference. If the question was provided to me that these are the min terms and these are the don't care terms, I would have proceeded with the question in a similar pattern, assuming that the don't care terms are also useful and treating them as min terms, but while preparing the PI chart I would have removed those don't care terms from the table, and that is the only difference which has to be kept in mind while solving the question based on don't case. So, with this we come to the end of the lecture. Thank you very much.